You see where all the numbers came from?
Yes.
Okay, now, the next line is actually doing the math on this. So the voltage of the cell is the standard voltage, that's the 0 volts. Okay, minus 0.03, where did I get the 0.03? 0.06 divided by 2 times. Now the log of 0.1 is negative 1. You can check it on your calculator. I think I'll do that, by the way. Okay, so 0.1 divided by 1 is 0.1. Hit my log button. Sure enough, it's negative 1. So negative 0.03 times negative 1 gives us a positive voltage. Good sign. It means, yes, we'll get voltage out of the cell. Now, again, notice it's pretty puny, the amount of voltage, but that's not important. We could always put a lot of these in series with each other. But you've now seen one of the trickiest things in the course, the Nernst equation, which allows us to calculate the voltage of any cell. Okay, now I'd like to put you in an industrial situation. So let's say you're working for a company, and the boss has some bromine liquid, and he's got some bromide ions. He has some magnesium ions and some magnesium solid. And he says, okay, I want you guys to build a cell out of this. And so you look up and you find these two half reactions with these two voltages. Okay, now the first thing you always want to do, by the way, notice I've given you reduction half reactions, which is the opposite of the chart you have, which is kind of good because you guys should be good enough to manipulate them. Now, the name of the game is you can't just blindly add these together so the electrons won't cancel out. So obviously you've got to switch one of these two around, and the question is, which one should you switch around? The answer is you always want to get a positive E0, so you got to switch this around so you get a positive value of the E0. So while you're figuring this out, I'm going to go on to the next chart. If I can't find it, you guys are going to help me. So notice I took reaction 2 and I reversed it. Why? Because by doing that, I get a positive voltage for that one. And so now I'm going to add two positives together. And so kind of eliminate 2 from your mind, and we're dealing with 2 in reverse. And notice I added these together. So the overall reaction is we have bromine liquid, magnesium solid, magnesium ions, and bromine ions. And I get an E0 of positive 3.46 volts. So you go to the boss, and the boss says, oh, okay, that's the voltage, but what does little 0 mean? And you say, well, that means standard voltage. And he doesn't know what that means, so standard voltage means the concentrations are all 1 molar. Now, the boss is not happy. He says, is there a way you can do better? Can you somehow change these concentrations to get a higher voltage? Now, notice I've left some blanks here because as a class, we're going to fill in those blanks and pick some different concentrations and see if we can get a higher voltage. Now, Berg, how do you do this? It's a matter of your old friend, Le Chatelier's principle. Okay? So, would you please pick a different concentration for the bromine of 1 molar? Let's see, I'll pick on some people. Okay, Abby, what would be a better concentration than 1 molar if you want to get a higher voltage? Now, the hint I'll give you is if you want a higher voltage, you want to shove the system to the right. So we need a giant more on the left-hand side. So what would be more than 1 molar?
2.
Give me a number.
2 molar?
2 molar, okay. Now, I was hoping I could write 2 molar in there. I don't think I can do that, but let's see, I'll try it. 2, nah, it doesn't write it. I'm sorry, I can't write it. Okay. So everyone on that first, would you put 2 molars there? And I've written it on a piece of paper. Okay, now look at, magnesium solid, we can't do anything with that. I mean, solids concentrations are just constant. But look at the magnesium 2. Okay, instead of 1 molar, what would be a good concentration to put that? Now remember, think of Le Chatelier's principle. If we want the system to go to the right, we want to make this a hole in the system. We want to make it less. So let's see. Luke, are you handy? Okay, so instead of 1 molar, pick a different concentration for the magnesium plus 2.
Let's go with 0.1 molar.
0.1 molar, I like that. Okay, and let's see, who else is handy? Can I think of? How about Jonathan? Are you around? Chris?
Also 0.1.
Okay, also 0.1. Okay, so now Here's the Nernst equation below. Okay, so I'm going to try to put these numbers in, and please would you check on your calculator. The first thing I always like to do is I like to do the log term first. Okay, so it's products of reactants. So you told me that the magnesium was going to be 0.1 molar. So I'll put in 0.1. And for the bromine, it's going to be 0.1 squared. So I'll do times 0.1 times 0.1. And just a check thing, I've got an answer now so far, 0.001. Anyone check that? And then I'm going to divide it by the reactant. That was a 2. So I'll divide it by 2 equals. Is anyone checking me on your calculator? I've got an answer of 0.0005.
Yep.
That is the mass action term. That was products of reactants. I'd feel better if someone would verify that.
Yeah, it works out.
Now I have to hit my log button. So I hit the log button, and I get an answer of negative 3.3. So the log of that was negative 3.3. Anyone verify that? Yes or no?
Yes.
I hope I did it right. You guys are making me nervous now. And we get a different answer? No one has a calculator? You're going to take my word for it? Okay. So now I'm going to do the next part. So times 0.06 divided by 2, which is 0.03. So times a negative 0.03. So times 0.03 negative equals, I get an answer of plus 0.099. And then I have to add to the zero, E0, so plus 3.46. So I get an answer, write this down, and you can check me later if I made a mistake, of positive 3.559. I'll round it off to positive 3.56. Anyone verify that? Nobody?
Yeah.
Okay, I heard a yes sir. Okay, now, the boss is not too happy. He said, wait a minute, the E0 was 1.46. We're only getting 3.56, only a tenth of a volt higher. Now, why is that? You know what the problem with the Nernst equation is? When you change the concentrations and you take the log, it doesn't change that much. So you know what? You guys were not drastic enough. So for homework, I want you guys to get really drastic, okay? So don't use puny numbers like 1 molar, 10th molar, and 10th molar. I want you to guys think big, and for homework, see if you can save my job and get much bigger voltage than that. Okay, so the last square of the day. Homework. Okay, so here's a homework assignment so you can practice a lot of things we've been doing in today's lecture. And I hope your brains are full, because that's all I have for you today. And any questions or comments at this point?